we're in lesson 8.2, confidence intervals for one population mean. When sigma is known, so sigma has to be given to you. The goal by the end of this lesson is to be able to calculate confidence intervals for critical values associated with the 90, 95, and 99% confidence levels. So first of all, there's a procedure. The procedure for the one mean z interval is, first of all, our purpose is to find the confidence interval for the population mean. And that's something that came up in your notes yesterday, was talking about finding an interval to estimate the population mean versus just a point, or a point estimate. A few assumptions have to be in place. First of all, that you're doing a simple random sample. So with the marathon runners, you had a simple random sample just put together in a paper clip or in a bag. Also that either the population is normally distributed or that it's significantly large. And the third thing is sigma has to be known. So step one, for a confidence level of 1 minus alpha, and we're going to cross out 1 minus alpha. This is based on a college text, and so we're going to simplify it just a little bit. We're actually just going to focus on the 90%, 95%, and 99% confidence levels. And instead of using this specific table that's sort of like our z-score table, we're just going to use the table, the generic table that is below. So whereas we could refer to this as z sub alpha over 2, and you know z is the z-score. I mean, we could make sense of this. In fact, if you'd like, you can take a look at the text and you can follow along in that process to calculate any confidence level. But for now, we're going to cross out the z sub alpha over 2, and we're just going to write CV. These are our critical values. We have 3 of them associated with the 3 confidence levels. So we've got the 90%. We're going to kind of cross through the 0.1 alpha. We're not going to reference that. Is 1.645. The 95% is 1.96. We said it was 2 for the 8.1 notes. We were just rounding, right? So now we're just a little more precise. And for 99%, we've got the 2.575 critical value. Step 3 in this process, step 2, I forgot step 2. We've got a formula. So rather than, I could cross out some parts here. Our confidence interval is equal to x bar minus, instead of the z sub alpha over 2, we're going to write CV. And again, CV. But that's kind of ugly, so let's just write it out on the side. So there's actually 3 ways that we're going to refer to the formula for the confidence interval. The first is just x bar plus or minus CV times sigma over radical n. The second one, x bar plus or minus CV. What's another more efficient way to write sigma over radical n?
Sigma sub x bar.
Good. Sigma sub x bar. And the third way, which we reference in the opener, we could replace this whole thing with what letter?
E.
E. Good. So we're going to write x bar plus or minus E. And just as a reference, since this isn't written anywhere else, make sure you define E stands for margin of error. Michael, will you read a fundamental principle of data analysis?
Yeah. Before performing a statistical inference procedure, examine the sample data. If any of the conditions required for using a procedure appear to be violated, do not apply the procedure. Instead, use a different, more appropriate procedure if none exists.
Great. This is our procedure. So if the conditions aren't met, we'll just say the conditions aren't met. But most of the time, the conditions will be met for our purposes. So here are the 3 confidence levels in this chart, and we'll walk through an example. So the confidence interval for, let's take a look at my X bar. My X bar was 237. So for our marathon runners, let's just write it out first. Let's do 99%. 99% confidence level. So that means I'm going to use the number 2.575. So X bar plus or minus 2.575, and then times sigma over radical n. I already forgot my number. So 237. 237 plus or minus 2.575 times sigma, which was 45.2, divided by the square root of 25. So calculate your E first. Raise your hand when you've got that calculated. The 2.575 times the 45.2 divided by square root of 25, or 5. You're going to want a calculator. Alyssa,
23.278.
anyone want to validate? 23.278. So 20, what is it?
23.278.
Let's do 23.3. And then we'll calculate the interval. So subtract the 23.3 and then add the 23.3. Gwen?
260.3 for adding, and 213.7 for subtracting.
Oh. Okay, do them again.
So it's 260.3 for adding,
Okay.
and then for subtracting it's 213.7.
Okay, good. And make sure that you put, obviously the smaller number would be on the left side of the parentheses and the larger number on the right-hand side, lower bound and then upper bound. Thanks, Gwen. Last step is, don't forget it, interpret the confidence interval. So the interpretation is interpretation. Ugh. It's not that hard. It's this E. There we go. Got it. So we can be 99% confident that the population mean mu falls between 213.7 and 260.3. That's the interpretation. Now, what did you notice about the margin of error with the 99% confidence level versus the 95%? Did it go up or down? It went up, right? So if I have a confidence, if I have a smaller confidence, I will have a shorter confidence interval. If I want to be more confident, I have to give more cushion. So if I want to be 99% confident, I have to have like a little bit more buffer. And so you'll see that that confidence interval length get larger. One more example, civilian labor force. Volunteer to read? Alyssa? Allie? Chloe?
The civilian labor force, the Bureau of Labor Statistics collects information on the ages of people in the civilian labor force and publishes the result in employment and earnings. 50 people in the civilian labor force are randomly selected. Their ages are displayed in Table 8.3. Find a 95% confidence interval for the mean age mu of all people in the civilian labor force. Assume that the population standard deviation of the ages is 12.1 years.
Excellent. So some key information that you read, 50 people in the labor force, 95% confidence. Yep. Standard deviation 12.1. Sort of like in algebra, it's good to write down the information you're given, then write down the formula, and then just plug stuff in. So we're going to write, okay, n is 50. My confidence level is 95%. You have to look up the critical value. You're going to start to memorize these. For 95% confidence level, we have a 1.96 critical value. .96 is my critical value. And then I have my sigma, 12.1. And finally, I need an X bar. We have one sample, so we could add those all up, divide by 50, and we would get 36.4. Lucky for you, first period did that. So now I write out the formula. Confidence interval equals X bar plus or minus CV times sigma over radical N. So 36.4 plus or minus 1.96 times 12.1 over the square root of 50. Calculate the E. Chloe?
3.35.
Anybody else? 3.35, validate? Yep, good. Then we'll go lower bound and then upper bound. So subtract and then add the 3.35 to and from 36.4. Alyssa?
33.05 and 39.7.
Anyone want to second that? 33.05 and 39.75? Okay, great. Lastly, we interpret. Try and write the sentence similar to the front. We can be 95% confident that the mean age of people in the labor force. I got a little more specific. It's okay if you're not. People in the labor force is between 33 and 40. Since most people don't refer to their age to the nearest hundredth. Maybe half. Rarely a quarter of a year, but not likely to the hundredth. So confidence and precision, just like I was talking about with the 95% confidence interval is smaller than the 99% because we need to have more cushion. It says for a fixed sample size, decreasing the confidence level improves the precision, and vice versa. Here's a picture of that. You can see it's 90% has a smaller length of the confidence interval than the length of the 95. So let's go ahead and calculate the lengths of these. Just subtract 39.2 minus 33.6. Alyssa? 5.6. Good. And I'm going to teach you a new symbol today. It's 3 dots in the shape of a triangle. It means therefore. So anytime you want to write therefore, you can just use that symbol in math. So therefore, the margin of error, not ME, we just use E. E equals 1/2 the confidence interval, or 1/2 of 5.6. So what do we get for the margin of error? Clear? 2.8. So we have our margin of error, we have our confidence interval for the 90%. Same data set, same mean, but now with 95%, we would do the length, of the confidence interval here is 6.8, good. And so the margin of error is going to be half of that, which is 3.4. So just for one example, we'll label that. 6.8 is the whole length of the entire confidence interval, and margin of error, the 3.4, is half the length of the confidence interval. So each one of these sides is 3.4. And so that concludes our notes on confidence intervals for one population mean.